Okay, so we're looking at induction type 2, divisibility. We're on question 9. We get 7 to the power of n plus 4 to the power of n plus 1 is divisible by 6. I put 1 in for n, I get 12, which is obviously divisible by 6. I assume it's true for n equals k. I have to prove it's true for n equals k plus 1. So unlike type 1, we don't start with our assumption, we start with what we're trying to prove and break it up. So 7 to the power of k plus 1 is just 7 to the power of k by 7. And 4 to the power of k plus 1 is 4 to the power of k multiplied by 4. And I've got my plus 1. Now let's keep an eye out for this. So it needs to be all divisible by 6. So I've got my 7 to the power of k. So my 7 is easy to turn into something divisible by 6. I can just express that as 6 plus 1. Now, my 4 to the power of k, I'm not going to be so much able to make it divisible by 6, but I can see that, I can see that in what I'm trying to prove, I'll get my 7k when I multiply that in there. I have my 1 because I have it at the end here, but I need to find a 4 to the power of k, but I won't get that by multiplying this in unless I split the 4 into 3 by 1. So if I split that into 3 plus 1 plus 1, when I multiply the 4 to the power of k in there, I'll get that 4 to the power of k that I need. So multiplying that out, that's 6 times 7 to the power of k plus 7 to the power of k plus 3 times 4 to the power of k plus 4 to the power of k plus 1. Alright, so putting all that together, I'll rearrange it so I have my assumption together. So I have 6 by 7 to the power of k plus 3 by 4 to the power of k plus my assumption, which is 7 to the power of k plus 4 to the power of k plus 1. I can take all of that assumed to be divisible by 6. Now, you can now say that 6 to the power of 7, 6 by 7 to the power of k is obviously divisible by 6 because it's multiplied by 6. This is the hard part here. It's explaining that that's also divisible by 6. Well, if we take it, for example, 4 to the power of, if k was 1, 4 to the power of 1 multiplied by 3, which is 12, which is divisible by 6. And then you'd have 3 to the power of 4 squared would be 36, which is a multiple of 12, so will also be divisible by 6. So all you're really trying to say there is that 3 to the power of 3 multiplied by 4 to the power of k is a multiple of 6 for all k. Perfect. So you say that so that's going to be your justification for this part. You justify this by just saying it's a multiple of 6 because 6 is a factor of it, and you justify that this is divisible because it's our assumption, and tie it all together the exact same way that I did for the first question in this sequence. So have a look at that.